Hello, everybody. Bonjour, buenos dias, and welcome to our webinar dedicated to PAS HYDROSYSTEM software, namely its latest version, HYDROSYSTEM 4.6. This will be the main aim of our today's webinar. First of all, allow me to introduce myself. My name is Sergey Lisin. I am PAS Support and Quality Assurance Engineer, and I'll be your host during this webinar, and I will be assisted by my colleagues, Ms. Yelena Yudovina, Mr. Leonid Korstein, and maybe somebody else. We'll decide it in a minute. And our agenda for today's webinar is as follows. So first of all, we're gonna say a couple of words about who we are, what we do, and what is our PAS HYDROSYSTEM software. Then we're gonna talk about some new features of the latest HYDROSYSTEM version 4.6, which was released a while ago. And then after that, we're going to have a questions and answer section. So if you have any questions during our webinar, please write it down in our questions and answer section here in Zoom. Not in chat, please, only in questions and answer section, because in chat, usually we have a lot of flood and sometimes we can find our own messages. So please write all your questions into questions and answer section. First of all, let's talk about a little bit about PAS Suite software. PAS Suite software consists of different software. It's HYDROSYSTEM, which is dedicated for fluid flow and heat and hydraulic analysis and sizing of piping systems. It's PAS Start Prof software, which is dedicated to stress, fatigue analysis, stability analysis, and sizing of pipelines. PAS Equip, which is dedicated to stress analysis for vessels, columns, tanks, heat exchanger, and other equipment. And Nozzle FEM software dedicated for nozzle shell junction stress and flexibility analysis. All of this software is very, very experienced, more than 50 years of some of them of non-stop development. And this software is very widely used for different types of piping systems, pipelines, equipment, etc., etc., etc. So for process industry and different industries, oil refinery, chemical industry, metallurgy, etc., etc. For utility networks, for oil and gas piping system, you can use all of our software. And our geography is very wide. Currently, our software is presented in 40 plus countries, and we have more than 3,000 active customers as of the moment, 400 customers outside the CIS, and we have a lot of partners, hi, and a lot of them partners outside CIS. And now let's talk a little bit about our HYDROSYSTEM software, what it is, what it does, what it's dedicated to. HYDROSYSTEM is very experienced software, as we prefer to name it. First, it was introduced in 1977. It was blessed by piping hydraulic world-known guru, guy named Idelchik. That Idelchik who wrote this famous reference hydraulic resistances book. And currently, HYDROSYSTEM is used by more than 600 companies worldwide. And we consider it as an ideal tool for day-to-day operations in designing of any piping systems of any complexity and almost any type of fluids. So what HYDROSYSTEM is capable of doing? First of all, HYDROSYSTEM is capable of performing heat and hydraulic analysis of steady state flow for different type of fluids, for liquids, for gases, ideal gases, real gases, wherever, for gas liquid mixtures, for gas liquid liquid mixtures, some three-phase flow, for instance, and for liquid plus solid mixtures, aka slurry flow. Also, HYDROSYSTEM calculates not only the steady state flow, it's also capable of calculating surge analysis, transient liquid flow, or as we call it, water hammer calculation. And HYDROSYSTEM is suitable for piping systems of any complexity, any number of inlet points, any number of outlet points, any number of branches, components. It doesn't matter, HYDROSYSTEM can deal with all of them. In HYDROSYSTEM, you can solve different tasks of hydraulic calculation. You can perform upstream and downstream pressure drop analysis. You can calculate flow distribution in piping system. You can size nominal sizes of your piping system. And in HYDROSYSTEM, we have very customizable and very detailed calculation results reports, where you can see all your fluid properties, velocities, pressure drops, on friction, on minor losses, etc., on heat losses, flow patterns, and many other parameters of our piping system. HYDROSYSTEM has very wide integration capabilities. It has two sides integration with PathStart-Prof. So if you work with these two software, you can easily drop your piping model from one software to another and vice versa. Also in HYDROSYSTEM, we have integration with PCF files, also both sides. So you can import PCF files, export PCF files. You can import and export DXF files, I mean drawings made in AutoCAD, MicroStation, CorelDRAW, and other software. We have our own neutral format file with neutral format files, which allows you to connect HYDROSYSTEM with your own third-party software. For instance, we have such integration with Aviva software, Autodesk software, Revit, and Civil 3D, and you can also make your own integration with your own software. And starting with latest version, and we're gonna talk about this in detail in a few minutes. We have an integration with AutoCAD. HYDROSYSTEM is capable of generate isometric solid 3D drawings using AutoCAD. In HYDROSYSTEM, we have very flexible licensing. So depending on your needs, you can select special modules of program which suit your needs, which will allow you to calculate what you want to calculate. For instance, if you need to calculate only isothermal steady-state flow analysis for a piping system, you need this module, which is called Hydro. If you need to also perform heat and hydraulic analysis, you will need additional module Thermal. If you need to perform analysis for multi-phase flow, you will need additional model, etc., etc. So depending on your needs, you can select the configuration of the program which will suit your needs and will cost minimum. And in HYDROSYSTEM, we have a lot of convenient tools that are always at hand. Among them, in HYDROSYSTEM, we have a different built-in libraries, thermodynamical libraries for fluid properties and equilibrium calculation. So in HYDROSYSTEM, when you work in HYDROSYSTEM, you can specify the composition of your fluid, and that's it. The program will calculate all the required properties and phase equilibrium for your calculation on the go. You don't need to enter these values manually. And we have a lot of different libraries for different type of substances built in HYDROSYSTEM. In HYDROSYSTEM, we have a gas-liquid flow analysis, and for this analysis, for two-phase flow analysis, HYDROSYSTEM is capable of build such thing called flow pattern map. This flow pattern map shows you what type of two-phase flow pattern you have in different pipes in your piping system. And it can give you some advices how to avoid some undesirable flow patterns. For instance, some slug flow, plug flow. Looking at this diagram, looking at this flow pattern map, you can decide what to do to avoid them and to escape them. And HYDROSYSTEM built this flow pattern map automatically. In HYDROSYSTEM, we have a special service of goal-seek calculation. We call it parameter selection. So for instance, if you want to size your pressure control valves, flow control valves, temperature control valves, you can say that I want to get a temperature or pressure or flow rate of this value over here. How I need to set up these valves, what KV or CV or another parameter do I need to achieve this. And the program will calculate this parameter in such value that allows you to control what you want to control in your piping system. So you can size pressure control valves and other control valves right in HYDROSYSTEM. In HYDROSYSTEM, we have a surge analysis calculation, and also we have not only the surge analysis, not only HYDROSYSTEM calculates all these pressure spikes and whatever, it also can show it to you right on the piping diagram, so you can see how the shock waves traveling across your piping system. It's very beautiful and it's very, very useful to understand what's happening at surge in this piping system. And in HYDROSYSTEM, we have an interesting feature, the feature that is not presented in any other software at this level as we have it. It's an expert of forces caused by flow to start proof for stress analysis. The thing is that in HYDROSYSTEM, we're capable of calculating some phenomena that may cause large forces on the piping system itself, on valves, elbows, tees, bands, etc., etc. For instance, surge analysis, when the shock wave is traveling in piping system, it may hit some bands or some other elements, or if you have a gas liquid slug flow, slugs also hit the different piping components. And sometimes they hit very hard, so it can move your piping system very drastically. So in HYDROSYSTEM, you can calculate the forces that induced by this phenomena, and to automatically export these forces to StartProf, to our another software for stress analysis, to visualize, to calculate what will happen with your piping system if those forces will occur in this piping system. So if you use both of these two software, HYDROSYSTEM and StartProf, you have some very, very tasty additional features. And now let's proceed to our main subject of today's webinar. What's new, what we have new in HYDROSYSTEM 4.6, in the latest version of the software. There's a lot of interesting things, and the first of them, let's talk about our main feature that we added in the newest version is a capability of calculating different fluids in one pipeline. For those who work in HYDROSYSTEM before, you know that in HYDROSYSTEM there always was a single fluid in whole piping system. It can be liquid, it can be gas, it can be multi-phase flow, gas plus liquid, but it's always the same for all components in your piping system. Well, starting with version 4.6, HYDROSYSTEM now is capable of calculating pipelines with different fluids compositions in different sources. So for each of your inlet branches, you can set your own fluid with its own composition. And if you have some mixing of different compositions of different fluids, the program will automatically calculate compositions at mixing. And of course, all the properties, all the densities, viscosities, etc., will be calculated also automatically. And in calculation results and in input data, you will see all the mixture compositions at every pipeline branches. Allow me to show it to you how it looks, how it works in HYDROSYSTEM. Here I will open some example, for instance, this piping model that I showed you on this slide. And let's assume we have two inlets over here, and here a part of our fluid goes from here to here on this bypass. And a part of fluid comes from here, mixing with this part, and then they mix with this part, and we have something at outlet. Usually, in previous version of HYDROSYSTEM, we could have only one fluid over here. Here I have some mixture of diethylene glycol and water. And now, starting with HYDROSYSTEM 4.6, you can add your own fluid for your different branches. For instance, let's calculate this. For this branch, for this inlet, I will insert the same fluid as here. Fluid composition. Yeah, it goes like this. Diethylene glycol plus water, 50-50 content. And for this branch, let's say we add some diethylene glycol, a little bit more, or a little bit more water or something like this. To do this, I simply select this branch, and I can add a additional fluid to this branch over here. I'm making it okay. And I'm gonna add another composition for this branch. For instance, it will be one single component, and let it be diethylene glycol. Okay, 100%, so pure diethylene glycol, which we add to this pipeline over here in this place. And that's it. We're ready to go. Allow me to perform, for instance, isothermal calculation for this fluid, for this piping system. And looking at the calculation results, we may see that we have a very different densities on different branches, which means that we have a little bit different fluids. So to visualize it all, we have a special button over here where you can see what is happening with compositions of your fluids in this piping system. So here I can see that here I have a 50-50 mixture. Here I also on this branch, yeah, over here. Here I also have a 50-50 mixture, and here I have a 50-50 mixture. And after we added here a little bit diethylene glycol, we have fluid composition like this in this branch. And after we add a little bit of mixture here, mixture plus mixture, we have a composition about 65 to 35% on the outlet. So now if you have some piping system with different fluids, with mixing or something like this, you can calculate it right here in HYDROSYSTEM. Currently, it's done only for one phase flow, for single phase flow, for liquids and gases, but in a future version, we add such capability for two-phase flow, for multi-phase flow also. Next, another interesting feature that we added in the latest version of HYDROSYSTEM is variables and formulas. It's our first stage to the full scenario manager. Unfortunately, currently in HYDROSYSTEM, we don't have scenario manager, but this option would allow you to use some advantages of real scenario manager. Now, in HYDROSYSTEM, you can add your own variables to simultaneously change or assign different parameters of different multiple piping components. For instance, valves opening, valves KV, flow temperature, etc., etc. And these variables can be used in formulas. So for instance, if you have very complicated piping system with multiple valves, and you want to calculate this piping system in different modes, in different regimes. For instance, in mode number 1, all the valves are open. In mode number 2, only half of these valves are open. In mode number 3, only 10% of these valves are open, and etc., etc. In previous versions of HYDROSYSTEM, you were forced to manually open and close each of these valves to perform this analysis for different modes. And if you have 120 such valves, that will be a very, very complicated task to open them, close them. And what's starting with this version of HYDROSYSTEM, we can simultaneously open them, close them using these variables, using their values. How to do this, how it's done, allow me to show it to you once again in HYDROSYSTEM. I'm gonna open another example, for instance, example of such type of piping system. Yeah. Look at this piping diagram. So here we have some fluid, I guess it's water. Yeah, it's water. And this water flows from here to 4 outlets, 4 ending points to here, here, and here. And let's assume that we need to calculate this piping system in 2 modes, in 2 regimes. Mode number 2 is when only left valves are open and right valves are closed. It's our mode number 1. And mode number 2 is when only right valves are open and left valves are closed. So if you have this type of simple piping system, you can manually open and close this valve and the problem solved. But assume what will be if you have not 2 valves over here and about tens of even hundreds of valves. That will be not very easy task to do. So currently in HYDROSYSTEM, we can do it much more easier. We have a special option over here for a pipeline on the parameter selection tab, which we used to have only automatic parameter selection, which is iterative analysis to achieve target parameters value. Now, along with this, on this tab, we have a manual parameter selection. What is manual parameter selection? It's a single time calculation based on certain control parameters that you specified, and you can specify these control parameters using variables over here. Allow me to open this variables window, and let's add a couple of variables. First variable I'm going to add here, it will be left valves opening. Left valves opening. Okay. And I'm going to add another variable, which I will call right valves opening. Okay, so I have two of these variables, and initially I will set their values to 0. And now, to automatically close this valve, I need to use these values in their parameters. To do this, I press OK here, and I go to, let's start with this valve over here. Here, for this, in another valve, on parameter selection tab, we used to have only control target parameters calculation. Now we have an option of manual input of these control parameters. So to do this, I simply press on this tick box, and I'm going to press this button over here, which opens formula edit. And here in this formula, I will use the variable left valves opening. Okay, so now this behavior of this valve will be directed by the value of this variable. So press OK. Now I'm going to do the same for this valve. Also selected, valve opening. Once again, left valves opening. And for these two valves, let's complete with them too. I'm going to assign for them right valves opening as their parameter. Here and here also, valve opening, right valves opening. So now these valves governed by the first variable, this by the second. And if I'm gonna perform analysis right now, as you can remember, both values of both these variables are equal to 0, the calculation will say that, parameter selection. I forget to switch it. Just a second. Yeah, I forget to switch it to manual. Once again, if I performed hydraulic analysis, everything will be closed because all the valves opening are equal to 0. So we don't have flow rates, we don't have velocities, we don't have anything. Everything is closed in this piping system. But if I go here to variables, and for instance, I will specify value of left valves opening equals 1. Okay. It will simultaneously open these two valves. And after the next calculation, let's perform analysis one more time. These two valves will be open. So now flow goes here and here. And these valves are still closed. And we see it in calculation results over here. Yeah. And if I want to calculate what will be in vice versa when this closed and this open, I don't need to specify each of these valves one by one. I need to go here to variables and now say that right valves are open, left valves are closed. Okay, okay. Calculate it one more time. And now only right valves are open. So if you have different scenarios, different modes at which you want to calculate how your piping system behave, you can use these variables and formulas in your own calculations. So specify as much as variables as you want to, assign these variables as parameters of your valves or your whatever, and by specifying the values on this variable, you can simultaneously change the parameters of multiple different objects, different components in your piping system. And now let's go to another interesting feature of our newest version of HYDROSYSTEM. Let's talk about 3D isometrical drawings. The thing is that starting with this latest version of HYDROSYSTEM 4.6, we now have an ability to generate 3D isometrical drawings right from HYDROSYSTEM. Well, not really right from HYDROSYSTEM. You will need AutoCAD for that. Well, if you have AutoCAD installed on your PC, HYDROSYSTEM calls AutoCAD, gives him all the data on your piping system, all the lengths, all the pipes, or whatever, and AutoCAD automatically generate this piping diagram, this scheme for you. And this will be full attributive model, so which consists of components for which you know their names, their sizes, so it will be attributive model. You can use viewports for this model. You can assign add some annotation to this model, some node tag, dimensions, and whatever. And also you can export calculation results also right into AutoCAD. We have a special predefined forms in which you can use calculation results. Once again, allow me to show to you how it's done. To use this option, all you need to have is you need to have AutoCAD installed on your PC. Currently, this function works only for AutoCAD, but we plan to add another platforms, BricsCAD or whatever, in future version of HYDROSYSTEM. For instance, we have a piping model of some gas discharge piping system, something like this. And if we perform analysis, let's say heat and hydraulic analysis, after that, we'll have a special option over here in File menu, which is called Isometric Drawing. So all you need to do is you need to press this button. ISO creation started, and now we have to wait about 10 to 15 to maybe 20 seconds because AutoCAD is running. Yeah, it runs over here. AutoCAD is not the sharpest tool in shed, so it will take about few seconds to generate this drawing. Yeah, the work is on, and after the ISO creation will be ended, we will see how this drawing look, what it has in it, and how it's done. Yeah, everything's completed. Let's look at what we have. We have a piping diagram like this right in AutoCAD. Once again, it's full attributive model. So as you can see, this model consists of different components. And here you have some lists to which you can add viewports of your model. For instance, let's add a viewport for our model, I don't know, maybe here, like this. Okay, and it goes like this. So you can zoom it, you can move it, you can do whatever you want. You can annotate then this drawing. For instance, you have here a special HYDROSYSTEM tab in AutoCAD where you can annotate viewport. Here you have some annotation settings. You can tag some single components, some node or some piping components or whatever. You can pass the table with calculation results. Let's start with some annotation. For instance, I would like to add annotations, dimensions, and node tag, for instance. Okay, to do this, I press annotate viewport. I select viewport, press enter, and it's done. Now we have all the nodes, all the dimensions, all written right on your viewport in AutoCAD. And if you want to put calculation results somewhere over here, let's add them to another list. You simply need to press pass table, select the table you want. We have general pipeline properties and summary results. Let's add some summary results and place them wherever you want. For instance, I want to place them over here. So yeah, this is all calculation results, or branches, or fluid, etc., etc., etc. So this is how it's done. This is how it works. It only requires AutoCAD installed on your PC. So if you want to get a full 3-dimensional isometrical drawing for your piping system, starting with HYDROSYSTEM 4.6, you are capable of doing this. All you need to do is have AutoCAD installed on your PC. And our next subject is import from DXF files, because starting with latest version of HYDROSYSTEM, we added capability of importing drawings, I mean the whole naked drawings from DXF files, a simple drawings that you can build in AutoCAD and Corel 3D, in MicroStation, and different drawing software. And in HYDROSYSTEM, we have a special intelligent recognition of all typical piping components, such as pipes, bends and elbows, reducers, valves, some equipment. We can import from this DXF file all the geometric parameters of the pipeline, pipe length, band radius, etc., etc. And this import support most of all the basic DXF drawing objects that exist currently. I mean lines, simple lines, polylines, 2D and 3D polylines, arcs, blocks, and whatever. And we can import separate layers from a DXF file. So if you have different things in your DXF drawing, you don't have to import them all into HYDROSYSTEM. You can import only your piping system, only your pipeline from this DXF file. Once again, allow me to show it to you how it works on some example. For instance, we have AutoCAD here. That's good. And let's add in AutoCAD from some DXF import example. For instance, I have a piping model, something like this. This is the drawing of my piping system. Here I have some pipes, some valves, some whatever. We're going to talk about it in a minute. And we can import this piping diagram right to HYDROSYSTEM. Allow me to show it to you how it's done. To do this, you need to press, in HYDROSYSTEM, you need to press File, Import, over here. And in previous versions of HYDROSYSTEM, there were only few several options available. We could import start profiles, neutral XML files, ECF files, and now, starting with the latest version, we added another option, which is called DXF files. I'm going to use this option over here, and I'm going to import this drawing that I showed you just a few seconds ago. When you import drawing, first what you will see is what kind of layers, all of them or not all of them, you want to import. Let's start with import all of the layers from this drawing. I will select all layers, okay. And this is how it's imported into HYDROSYSTEM. So everything you have in your drawing, including this table or whatever, will be imported. So the first advice we'll give you if you want to import DXF files, place your piping system in some separate layer, so you don't have to then clean your piping models from undesired elements. Or here in this DXF file, I have this table in one layer, and I have a pipeline system in another layer. So at import, allow me to import it once again. Let's import this file. But this time, I'm not going to import all the layers. I'm going to select only pipeline. So I want to import only this layer. Okay. So my model will consist only of piping system, not all the rubbish that may be presented in this drawing. And let's look at this model. Let's look what we can import from these DXF files. First of all, we can import lines, different type of lines. Here I have in this DXF model a simple lines. Here I have some polyline, two-dimensional 2D polyline. Here I believe I have 3D polyline. Yeah, they're all imported as pipes. So all of this are pipes here in HYDROSYSTEM with corresponding lengths. Also, from this drawing, we can import arcs. Arcs, here I have arc here, etc., etc. All arcs are imported as bands and elbows. Only if they're drawn. So for instance, here I have elbows, here I have arcs, they're imported. And for instance, over here, I don't have any arcs. So in this place in HYDROSYSTEM, you will see how two pipes are connected with each other without any arcs. So if you draw them, they will be imported. If you didn't draw them, they will not be imported. Also, in HYDROSYSTEM, we can import these valves, but to be able to import them, they should be specified in this drawing, in this DXF file, as blocks. So this is one block, this is another block. So if you simply draw it as multiple lines, for instance, let me explode this guy over here, this valve. Oh, just a second, I'll move it to pipeline layer. Okay, over here. So now look at this. I have one valve as block and another valve as few lines, few different lines not connected to each other. And if let's save it, allow me to save it, for instance, as DXF import example 0.1, something like this. And if I will import this 0.1 modified DXF file, let's look on how it will be imported. Yeah. Okay, pipeline only. Okay. It will be imported like this. So this valve is imported as valve. This valve is imported as several pipes. So because they're drawn as lines, so lines are important as pipes. So when you draw your piping system, if you want to then export it to HYDROSYSTEM, please draw your valves and all your reducers and whatever and other components as blocks. The same goes for another piping components, such as, allow me to show it to you over here, reducers and equipment. They're all imported to HYDROSYSTEM as corresponding components, reducers, equipment over here. So currently that's it. That's all components we can import from these DXF files. For instance, here I have some circles over here, and these circles are not imported, so there's a void, there's a gap between them. So another piping components are not supported currently, but if you have some your own piping components that you draw in some way, please let us know. We're going to add them in a future version. That's how it works. That's how it's done. Another last thing I want to say about it is when you draw your piping system in some AutoCAD and some drawing instrument, please make sure that all your pipes in this pipe are connected, because if you have some inaccuracies, for instance, here in this point, I have a small, very small, a few millimeter inaccuracy between this line, between this line and this line. They're not connected to each other, yeah? As you can see, we have a small gap. So if you have this gap here, you will have this gap in HYDROSYSTEM also. Let's look at this point over here. As you can see, this pipe is not connected to this one. So you should either draw everything very precisely, or in HYDROSYSTEM at import, allow me to import this file once again. At import, we have a special option which is called the largest allowable distance between connected lines, where you can specify your maximum inaccuracy in your drawing. So for instance, in this drawing, I have an accuracy about a couple of millimeters. So I'm gonna increase this allowable inaccuracy to 10 millimeters, for instance. And after that, if I will import it this way, let's look at the same diagram once again. This time it will be imported as a single point. So now 3 pipes are connect each other in this dot. So this option is dedicated to simplify this inaccuracies, work with inaccuracies in your DXF file. So if you have any of your piping systems already drawn in some drawing instrument, generally, let's say, in AutoCAD and MicroStation and CorelDRAW and any other drawing software, in every drawing software, you can save your drawing in DXF file, DXF format, and then import it into HYDROSYSTEM. As you can see, the major components will be important. The only thing that is not presented in this drawing is diameters. Diameters, we don't have them in DXF files. So when you import your piping models, there will be no diameters. So diameters you can specify here in HYDROSYSTEM after you import your drawing. For instance, you can select all the branches and assign them the same diameter or different diameters, whichever do you prefer. So diameters are not imported, but all the rest imported. Very good, like this. And also, in newest version of HYDROSYSTEM, we added a new licensing system. And I think the most advanced, most good news for users is that now, currently in HYDROSYSTEM, we support remote internet licenses. So usually, before in HYDROSYSTEM and on our other software, we're connected to traditional local hardware dongles, local or network dongles. Now in HYDROSYSTEM, you can use it using the internet license, which doesn't require any hardware dongle installed on your PC. All you need to have to use this remote internet license is a stable internet connection. That's it. So if you have internet on your laptop or on your PC, that's all you need to have to make this license work. You simply connect HYDROSYSTEM to our HYDROSYSTEM automatically connects to our licensing server and takes licenses from there. But also all the normal licenses like hardware local dongles and network dongles are also supported, and we support now currently some new modern dongles formats. So we added in our new licensing system too. And also we upgraded our automatic software update system. It's been improved, and currently it allows you to automatically update these hardware dongles too. So for instance, if new version of HYDROSYSTEM is released and you need to update your hardware dongle, all you need to do is run HYDROSYSTEM, and if your PC is connected to the internet, the HYDROSYSTEM will find this update, and if necessary, it will automatically update your hardware dongle if you use it. So starting with HYDROSYSTEM 4.6, everything will be a lot easier than it was before. And we have a lot of new other features. Among them are currently we allow to manually enter the thermal conductivity and other parameters of thermal insulation for some quick analysis. We're now allowing setting and considering the compressibility coefficient of liquid at water hammer at surge analysis. In previous version, when you were calculating water hammer, for more precise calculation, you were forced to use libraries, thermodynamical libraries, because only libraries were able to calculate this compressibility coefficient. Now, starting with latest version of HYDROSYSTEM, you can specify it manually at manual liquid properties input. So for instance, if you add your own liquid to the software, now you can specify this compressibility coefficient to perform the shock wave velocity calculation more accurately. Also, in newest version HYDROSYSTEM, we've added display of kV value for valves in report with calculation results. We upgraded our profile plot generation. Now it's capable of automatically generate plot for return pipeline basing on the results of calculation this current pipeline, if this return piping system is presented in this piping model. We have some improvement in software diagnostic system. Now we're showing the list of branch where your flow rates were recalculated for some reason. For instance, you specified boundary conditions incorrectly or something like this. Now we're showing elements with unspecified insulation thicknesses. We diagnose negative pressure more well than before. Well, a lot of new improvements. And we have updated our import modules from Eviva, from PDMS, E3D, from Marines, some new features added, and so much more. The list goes on and on and on, but unfortunately we don't have much time to name them all. And now to useful things, useful links. The latest version of HYDROSYSTEM is already available. You can download it from our website using this link or using this QR code over here. Not only the newest version itself, but also its free viewer of this version that allows you to open HYDROSYSTEM files. You can use automatic updates to get the updates of this version. And if you're not a past HYDROSYSTEM user at this moment, you can request a free trial using this link, free 30-day trial with no limitation in functionality. So you will have a HYDROSYSTEM in the flesh for 30 days, where you can perform your calculation, import your DXF files, generate your isometrical 3D drawings, and whatever. This is available using the link over here. And for more interesting lectures and webinar and all the stuff, please visit and subscribe our YouTube channel, which is available on this link, YouTube Pass Suite, or using this QR code over here. So that's it for today. I would like to thank you for participating in our webinars. I would like to remind that we have email that we have our WhatsApp where you can write, ask your questions, etc., etc. So if you need any assistance, we'll be online.